when you are considering is with respect to a ductile detailing the seismic loads point of view, this should be a continuous top steel and bottom steel in the form of a loop, that is in the form of staple bar is considered. Now we'll see a detailing of a cork bulb that is used in industrial structures. Not this is a cork bulb, this is a tapered cantilever beam. Sorry. Now we'll see the detailing practice of a tapered cantilever beam. When we are coming to the tapered cantilever beam, the detailing is also similar to a. The only difference is there is some sort of requirements with respect to the. With the equal spacing. When we are not considering the torsional into the structure during the analysis stage, this side face reinforcement will come into picture when the depth of the beam is more than 750 mm. When we are considering the torsion in the design, the 450 mm is the consideration, that is the beam depth at the end. And when we are not considering the torsion in the analysis and the design stage, uh, the 750 mm is a criterion. When the beam depth is more than 750 mm, in that case, the side face reinforcement at the rate of 0.1% of the web area, which is equally distributed on the both the faces, with minimum two numbers on each face is to be provided, which is equally distributed. Other provisions, what we have discussed earlier just now, is valid for these tapped beams also. That is the 50% curtailment up to LDR zero point 0.5 span, or the bottom reinforcement of minimum 2 bars are the top steel by 4. That is to also be anchored LD by 3 into the column zone. The bottom steel is to be treated as a primary steel when it is consideration with the seismic detailing or the seismic excitation in terms of the vertical excitation is considered. All these model provisions are the detailing practice are similarly valid for the tapped beam also. In addition to that, the minimum depth consideration will come into picture, and also the side face reinforcement will come into picture when it is a tapered beam, and also the prismatic beam also this web reinforcement is important. For the tapered beams, the torsion problem is much severe when compared to a prismatic cantilever beam. Now we'll see a quad bulb that is generally come across in industrial structure. We'll see once again, being a complicated detailing is there. We'll have a once again the detailing observation. We'll see. Now we are seeing the detailing of a corbel, generally that will come across in an industrial structure, where to transfer the eccentric loads that is coming on the column, the corbels will be used, which supports the gantry girder reactions. That is, gantry girder steel section will be placed here. It will transmit the end shear of the gantry here, and also it will transmit the horizontal EOT crane thrust that is coming due to the crab movement and all that will be at this junction. Therefore, the corbel is a element which transfers movement, axial force, and also it transfers the horizontal force that is to the supporting column. The detailing is very important, similar to in a cantilever beam. The small mistake in the corbel will generally lead to a failure in the corbels, generally that will have come across during the practical situations. In this, we have the three types of steels will be there. This is the green steel, that is a main steel for the flexural bending moment point of view. That is, what is the bending moment produced by this gantry reaction with respect to the CG of the column, this eccentricity of the load between the gantry reaction is an shear to the central line of the column. This eccentricity into the load will produce a moment. This will offer you the moment that was there in the corbel column junction. That moment is transferred to this main steel that is in the form of green steel here. And this is the flexural tension steel that was there. And this is the bottom steel, that is the minimum steel here. This can be put as a separate bar from this location to this location, or it can be a continuous bar like this. From this bar to this bar is a continuous bar we can provide like this. And we there is a shear requirement, that is the shear that was there has to be transmitted at this interface. This for the shear requirement, it is to be designed for the shear as a corbel shear we have to design. And these are the red color marks are the shear reinforcement that was provided. In the case of a corbel, the shear reinforcement is very, very important in addition to the your flexural reinforcement, that is the green reinforcement. Why? Because the shear is a critical one in the case of a corbel. The principal, it is a shear beam, that is the deep beam, it's a deep beam, where predominantly it's a shear behavior is predominant. Therefore, in order to ensure that shear capacity of the corbel, we have to ensure that the stirrup should be properly and correctly placed within the your corbel that was provided. In this, the development length of the main tension steel comes into play. That we should be calculated from this phases of the column. That is, from this phase of the column to this end, it should have the development length. And from this point to this point also, it should be development length in compression. This is development length in tension, and this is the development length in the compression that is to be met with. Whenever there is a insufficiency in the meeting of development length and compression up to this point, from this point to this point, we have to extend this bar like this. That is, this bent up bar like this in this fashion should meet the development length in the compression for this bar. And for this location, from the face of this outer face to the column to this point, it should be development length and tension that should be met with. And the shear stirrups, what we have calculated for the design shear, should be accommodated within a depth of 2D by 3 only, not up to this point. That is, what is the numbers that is required, say in terms of the number, not as a spacing, we have to specify. Generally, if we are spacing in terms of the corbel, it's a wrong detailing practice. We should specify in terms of it's a number. What is the three numbers of 8 two-legged stirrups or four-legged stirrups? So in that fashion, we have to specify. Or five numbers of 8 two-legged stirrups. That should be spaced in a distance of 2D by 3. That is 67% of this depth only. As it is shown in this, these are the nominal setup that was provided. The within this 2D by depth only, the stirrups are effective in resisting the corbel shear. That should be very taken care of, and the detailing should be with respect to the number, not as a spacing. Suppose we are spacing specifying as a spacing, we can provide the total numbers in terms of spacing. Will say that my design is correct and my detailing is correct. That is not correct actually. The number should be specified, and that number should be accommodated within the distance of 2D by 3 from this face only. That is very, very important in the case of a corbel is considered. And one more requirement is the closely spaced ties in the columns at this king position. That is, at this location, there is an outward thrust that is acting on the this bottom steel. To take care of this outward thrust that is coming from the bottom steel, we have to provide a closely spaced of not more than 150 mm spacing at this location up to a distance of LD. That is, LD distance we have to place a closest space tethers. It is spacing of 100 mm, 125 mm, but not more than 150 mm spacing. We have to provide the closely spaced tethers in this action to take care of the outward thrust that is generated. This king portion of the bent up portion. These are the very important points that is necessary for the detailing of any Corporal detailing is considered. And also we have the arrangement of instead of these horizontal ties, we can have the inclined stirrups also we can provide. Also vertical stirrups also can be provided for the shear reinforcement. But the horizontal stirrups are much more effective in the case of a cobblestone is considered. This type of standard detailing is to be adapted. Even though the permitted practice is to have the vertical stirrups and also the inclined stirrups is also permitted for the shear reinforcement, but this gives you a better way of detailing up for the corporate store. One more important point that is to be necessary is we have to provide a bar at this junction. That is a corner bar is to be provided. That prevents the splitting of the concrete as due to the diagonal tension here. There is a possibility of a tension crack that is developing along this direction. That is called the diagonal tension cracks. Similar to a lip angle we provide in the case of a ridge expansion joints. Similar to that, a lip bar we can have a corner bar we generally call it as here. That a corner bar is to be provided at one number. If possible, it should be welded to the stirrups of the mainstay, which give you a proper anchorage and the proper bonding and proper placement. Also, we should be provided one number at this junction. That is also very important. We'll see once again. This is also a typical one. We'll see once again. In part one, we have seen a column which is concentric with the bottom floor. That is, here we are detailing of the column with respect to varying size and also with respect to the floor levels, different floor levels. That is, in the earlier case, we have seen a column with reduced size with respect to the floor level. That is a concentric with respect to its centroidal axis of the what is the principal axis bending is there, it is concentric with the both major axis and the minor axis. We have seen that as a tapered column, tapered way of reinforcement of the bars with a tapping angle of not more than 1 in 6. How it is to be tapered and the location of the tapping also we have discussed with a practical mistake that took place in my own construction site also I explained in the previous part 1 lecture. In this, we'll see a case where a column is varying with the cross section with respect to its floor level, how the reinforcement is to be detailed. In the previous case, it's a concentric column where there is no eccentricity of the load is there with respect to the top and bottom columns. Here, there is eccentricity of the load with respect to the uh, geometrical dimensions, that is a cross-sectional area we have, and the column is flushed with respect to one face, that is the top column is flushed with one face of the bottom column, that is generally towards the outer face. In this case, how it can be done we'll discuss. In this, the starting bars, that is starter bars of the topmost column where the column is of a reduced size, should start from the bottom of the beam. That is first important. And second one is up to a development length of LD. There should be a closely spaced stirrups, that is up to a distance of LD, with a spacing of not more than 150 mm, or it should be specifically designed. Uh, in such a case that it should start from the bottom of the beam and extend up to a distance of LD, and with a enclosed by a closest steps of and pitch of not more than 150 mm. And these bars will extend to the topmost column of the reduced side, and the ends there should be a bending of this bars when it is flushing with the beams where there is no further continuation of the column is not there. That is, this bar length should be equals to LD. Generally, we come across and do the practical mistake of we provide extend the bars about the slab top without meeting these development requirements into the beam. For the sake of future extension and also for the sake of constructing some big pedestrians and all that, we simply leave that bars at the top where there is no possibility of future expansion of the building is there. But is that is a correct incorrect practice of the bar detailing when there is a termination of the floor is constructed. These bars should have a development length of LD like this and subject to a minimum of 300 mm. This bar subject to a minimum of 300 mm should be extended up to L by T when there is no further flow continuation is there. That is the one condition that is to be met with. And the second condition is the second condition is with the uh, the starting of the starter bars of the lower column size that should take place with respect to the bottom of the beam of the higher column size that is in the bottom column, and also the confinement reinforcement that is provided in this starter bar joints. These are the very important parameters that is necessary for the columns with the varying size. For the design point of view also, we have to consider this eccentricity whenever we are planning the hmm, reinforcement in this pattern that is with due to the digital column stage should also be taken during the design stage. And also during the detailing stage, one more important point is that the bars that was there in the bottom stage is better to have the continuation to the top steel in the form of a standard detailing practice is there. That is, these bars anyhow we are providing a new bars due to the curtailment, and these bars should be at least a side bars that is from the bottom bar, thereby the 50% curtailment condition can be satisfied very effectively. That is, the bottom bars that was there that should be have a continuation, and this bar can be a new bars that is meeting with the requirements of the reduced column size. That is important. Shall we continue in the next session, sir? ఇంకా చాలా ఉన్నాయి. నెక్స్ట్ దాంట్లో కంటిన్యూ చేద్దాం. ఇంకా 6, 7 పైన ఉన్నాయి. 6, 7 పైన ఉన్నాయి. నెక్స్ట్ దాంట్లో. Uh, Being a lengthy session, we are giving a uh, temporary pause to this previous presentation. We'll continue in the next session as a part 3. In that, we'll see the remaining parts like tapped columns, like three pile group, and staff footing with the practical execution, and a cantilever slabs which is supported on the cantilever slab which is supported on the four beams, that is the edge spandrel beams and the cantilever beams. What are the general mistakes generally we come across, and also what are the standard detailing practices? All this will be discussed in the part 3 session of this webinar. Up to this uh, uh, part we are covering in this part 2. Thanks for your patient listening. Now it's the time for the questionnaire.
Excellent, sir. Good morning.
Good morning, sir. Sir, shall I have?
Yeah, in Cardinal, you said horizontal bars.
Sir,
And
shall I take 1 minute gap, sir?
please, sorry.
No problems.
చాట్ బాక్స్ వల్ల 2 క్వశ్చన్స్ ఉన్నాయి.
చదువు మీరు చదవండి.
మీరు ఈ వీడియో ఆన్ చేసుకుంటే షేరింగ్ ఆఫ్ చేస్తున్నారు.
షేరింగ్ వద్దంటారా?
పీపీటీ స్కాన్ అది మరి మీరు విజిబుల్ ఉండాలి కదా.
చాట్ బాక్స్ చూడమంటే చదవండి.
Sir, it shall be common. Sir, there are questions in chat box. Suresh Babu Penmati, sorry, Pamarthi. Sir, it shall be comfortable in legs stirrups are explained. Say two left legs stirrups is needs. Some senior persons Engineers also use the word stirrups instead of using lateral ties in columns. This needs some attention. Use of correct word in buildings.
Shall you repeat once again, sir? In case of patient. It shall be comfortable with that. Excellent. Mhm. Hello, sir. Am I audible, sir? Uh, Regarding one of the questions in the chat box, it is the question from engineer Pemmati Suresh Babu, sir. His question is, it shall be comfortable if the leg of stirrups are explained, say two-legged, four-legged, six-legged stirrups in beams. Some senior engineers are also use the word stirrups instead of using lateral ties in columns. Uh, this needs some attention to the correct word in buildings. Actually, when coming to the beams, we use the term stirrups, that is in the form of a two-legged or four-legged or six-legged or eight-legged stirrups. The stirrup is a correct word in the case of a beams is considered, uh, which is specified with respect to the number of legs that is effective in resisting the shear. Not only the spacing and the diameter of the body of the stirrup is important, its number of legs that is resisting effectively, which was assumed during the design stage, is also to be represented in the detailing practice. That is, suppose two legs, we are saying that two legs should be there in the stirrups. That is, if we are saying four legs during the design stage, that four legs should have the effective resisting during the detailing and the execution stage. That is the importance of the stirrups spacing and the stirrup legs mentioning of the bars. When coming to the tie is a word generally used for the tension members. There is a common parallels in the structural engineering point of view. Tie is a strut is a compression member, and tie is a tension member. That is the general terminology used in the center materials or the structural engineering terminology is considered. When coming to the columns, we can use the term a stirrup or it can be used as a lateral tie. We are using the lateral ties means the tie, the what is the hoop tension that is generated in the column uh, lateral ties is representing the tension member effect that was taking place. That is, the principal resisting force is the hoop tension in the case of a lateral ties in the columns. Therefore, we are using the term tie. Suppose we are using the term stirrups in the columns, there will not be any difficulty, but it leads to some sort of confusion to the starting budding engineers. We can use the term lateral ties to the columns and stirrups to the beams. That is a standard practice we have. Regarding the second question, Am I audible, sir? Fine. Regarding the lintel and the sunshade is considered, the main problem that comes is with the lintel beam depth. Generally, the lintel beam depth is generally out of 6 inches to 8 inches, not more than that. Taking 8 inches into the consideration, the what is the important steel requirement is the development requirement from the face of the column, that is the face of the beam towards the outer side. Uh, Being a lintel is having a limited depth, say 8 inches or 6 inches, the development length requirement of the main steel will necessitate the steel to be looped into the rectangular stirrup-like fashion. That is, it's better to have a, suppose we are using some 8 bar in the sunshade. That 8 bar can be fabricated as a straight bar for the main steel into the sunshade, and the same bar can be utilized as the form of a stirrups by placing the form of a stirrup anchor reinforcement. That is, it will have a both functions of the stirrup in the lintel beam and also the main steel that was in the sunset top steel. That is the better way of arrangement. What you are, that is meeting the development requirements also, not only the tension steel requirements of the cantilever, the chajar, the cantilever, the what portico, or we can say cantilever, the sunshade. In addition to that, the development length can be met with by in the form of a stirrup enclosement that meets the development requirement and also the stirrups requirement of the your lintel beam. If you are not providing in that fashion, you have to construct a lintel beam and you have to place a top steel of the sunshade in the form of a loop, which is forming around the lintel beam outer the main steel. That is the four bars of the lintel beam outer side, similar to a scanner, and such that the development length requirements are met with. What you are specifying is, instead of that pattern, whether we can provide a sigma type of fashion. In that case, the placing of drop down of the tension steel up to the bottom depth of the sunshade will be a somewhat difficult problem. The general principle of detailing is that any tension steel that should be anchored in the compression zone, and the zone steel, that is the compression steel, should also be anchored into the compression zone. Why? Because in the compression area there will not be any development of tensile planes. Therefore, what is the effective compressive concrete bonding stress is there will be fully effective in offering the bearing stresses over the perimeter of the steel due to the proper bonding. That is the compatibility of the strains using which we are transferring the stresses from the steel to concrete or from the concrete to the steel. The better way of bond stress can be what is the tau BD, or what we call it as interface shear value, that can be better transmitted by way of anchoring into the compression zone. The better possibility can be possible only when the tension steel that is wrap around when coming from the sunshade to the lintel beam is a wrap around similar to a stirrup that was there when compared to a sigma type of arrangement. Any questions, sir?
I request Mahinder to ask his question, which was updated.
Any questions from the past participants, sir?
Sir, may I ask one question?
From participant side, sir.
Yes, sir. Sir, may I ask one question?
Please go. Sir, please go ahead. Please go ahead. Please go ahead.
Sir, as you said, columns at the top of the end, all the bar should be bent.
Hmm.
So this is for all the cases, means, and it should be bent in the beams?
Yes, sir. For the topmost story where we are not supposed to have further floors, that should be bent to the in the beam steel reinforcement that was detailed in the SP34 also. The after the bottom of the beam, it should anchored up to a depth of LDR subject to minimum 300 mm. That was detailed in the SP34 also. That is an inevitable situation. Why? Because your fixity conditions or the rigidity conditions will be effective and taking place only when there is a full development length of the steel that was there. Once you are not providing a full development length in the anchorage zone or the compression zone, where that is to have the full tension to mobilize in the bar, there is a always a condition of lead to partial fixity or no fixity conditions. If the development length is less than LD by 3, you can have a simple support connection at the beam column junction. That is the case. Especially for the seismic resistant point of view, the beam column junctions plays an important role in transferring in the shears and the moments.
Okay, sir. And how is the detailing, sir, at junction when the cantilevered wall is designed as a proper cantilevered retaining wall?
Sir, shall you repeat once again, sir?
Yeah, for retaining wall,
There is a
when it is designed as
yeah,
a proper cantilevered wall,
ah, that
so how is
is it
detailing
a
at the
cantilever
junction?
wall or a
It's a
proper
proper cantilevered.
cantilever wall? It's a building structure or the retaining wall you are saying?
No, retaining wall with the building. I mean basement
Ah,
wall.
basement wall you are saying.
Yeah.
Yeah. Regarding the basement wall is considered the generally how you model the your retaining wall at the ends is important, sir. Whether you have modeled the, as a the structure, suppose you are considering as a basement wall, whether you are considering the plate supported on the three edges or the plate supported on the two edges, or you are simply designed as a cantilever the stem wall, that is important, or whether you consider as a plate support on the four edges. That is, within the building frame, you are providing the your basement wall. That is in the form of a some sort of earth retaining structure you are providing. For this, the edge conditions of the plate, that is the in terms of the stem placed into the road. Suppose you can support as a on the three sides you can support, on the four sides you can support, or within the three sides of you have support, you can assume that there is a release of the movements at the plate. If you are assuming that in the design stage there is a release of the plate edge conditions, that becomes a cantilever action of the plate. In that case, you have to anchor the side reinforcement up to LD by 3 only into the column face, and not more than that. Once you are anchoring more than LD by 3, that leads to a fixed condition. Why? Because you already assumed in the design stage and the analysis stage that it's a release of the plate edge movements at the vertical face of the column. Bottom condition, there is no inevitable situation. That is the case of a fixed support condition. The sides, there is a choice you have. Suppose in the during the design and analysis stage, you have assumed that there is a release of the plate movements. That is the your the stem of the plate movements. Then in that case, if the assumption is in the analysis and design stage, release of the movements, you have to anchor the bolt up to LD by 3 only, not more than that. If you have considered the fixed conditions at the sides of the plate, then you have to anchor up to the full development length. When coming to the top end being a proper condition, you are saying, in the case of a proper condition, only we are transferring the vertical loads. It's a something like a simply support condition, simply support edge. There is any movement transfer is there. For that, also you should not anchor much more beyond LD by 3. If you are anchoring much beyond LD by 3, there is a partial restraint. If you are embedding up to full development length, there is a full flexibility is there.
Okay, sir. Okay. Sir, when the case of LD by 3, it is just a anchoring length, not a
Yeah.
fixity.
Yeah, just minimum anchorage length for the point of view have continuity of the bar without any fixed place, sir. Beyond LD by 3 to full development length, partial fixed tree, up to full LD, you have the fixed distance.
Okay. Okay.
Like in the steel structures, we have now semi-rigid connection joints are there. Like previously, we have the rigid joints and the simply support joints are the release conditions is there. Now we are designing for the semi-rigid joints. Similar to that, the condition will be there. LD by 3 up to LD by 3 to less than that. LD by 3 to LD beyond LD. That is the case.
Okay, sir. Yeah. Sir, may we get this video since I was little technical error. Due to technical error, I was joined little late.
We'll share it, sir, to
Sir,
yes platform.
we have a YouTube recording, sir. We can search it in YouTube. Is it clear, sir?
No, I have not heard, sir. I could not heard. Pardon?
We have YouTube streaming, sir. You can search
Okay, okay.
ACCA Kakinada Center. We have all the recordings of our sessions.
Okay. Thank you. Thank you. Yeah. Yeah. Thank you, sir.
Okay, sir.
Yeah.
Yeah, thank you. Any questions from participants side? Sorry. Sir, Sundar sir, shall we conclude session?
Sir, thank you, Narasimharao garu, for your valuable lecture. And I request Durga Prasad garu to conclude the session. Thank you.
Thank you, sir.
Thank you, sir. Thank you, sir.
It's my thanks for vote of thanks. Thanks to Chairman Sundaragaru for his initiation and energetic support in this webinar organization. My sincere thanks to Dr. K.V.Narasimharao for his valuable time and efforts in preparing presentation and sharing his valuable knowledge to all our members and participants. Thanks to member participants from long distances. My thanks to ACCA. My sincere thanks to all of my ACCA members, student, faculty, co-engineer friends, managing committee, member Sairam for his support from even though in his work. Thank you, Sairam. Thank you all. We are concluding the session, today's session. Thank you.
Thank you, sir. Thank you.
బాక్స్ ఇడ్లీ ఏదైనా స్నాక్స్ ఇస్తే ఇడ్లీ ఇస్తే మళ్ళీ 11:30కి అంతకు అవుతుంది 11:40కి వచ్చేటప్పుడు బస్సు ఎక్కి రావాలి ఫ్రీగా మనకు ఆధార్ చూపిస్తే చాలు వచ్చేటప్పుడు ఇది నాకు పికప్ కుదరదు నేను వెళ్తాను కాబట్టి మార్నింగ్ ఇంకా త్వరగా లేచి ఇదైపోతుంది చదివే టైం ఉండదు పొద్దున్నే బస్సులు అది చేయకపోతే మళ్ళీ క్లాస్ టైం ఉండాలి కదా 7:40 కంటే బస్సులు శ్రమ ఉండదు బట్ క్లాస్ కి